Good afternoon, everyone. Welcome to the next webinar in Passerelle's live webinar series. And today we're privileged to be joined by Dr. Maxime Sasseville for his presentation on scientific writing and generative AI, increasing productivity without compromising integrity. So thank you so much, Maxime, for being here today. I just want to do a brief introduction. So Dr. Maxime Sasseville is an associate professor at Université Laval and a researcher at the VITAM Research Center on sustainable health. His work focuses on the responsible integration of artificial intelligence in health research and practice. He is the creator of course offered through Laval, COM 7940, Scientific Communication and Publication, a graduate level course offered at the master's and doctoral levels that trains researchers in argumentation, peer review, and the standards of scientific writing. And it's open to students from all disciplines. And so with that, we will get started here. Just a few brief notes for our audience. The webinar today has live translation enabled. And so if you'll notice at the bottom of your screen, you can click the captions button. And there's the option there to change the translation to the language of your choosing there to make it more accessible for all users. And before we begin, I just want to take a moment to recognize that Passerelle's central office is located, is situated, on what is known as Quebec City, on the traditional unceded territory of the Huron-Wendat, the Innu, the Malasite, the Atikamekw, and Abenaki people. And in the spirit of respect and reconciliation, we extend our gratitude to these nations for their stewardship of this land. As we work towards a research future that's more inclusive and puts the patient and the public at its center, let us also make a commitment to educate ourselves about the rich Indigenous heritage that helps shape our collective journey. And let us move forward together by embracing the wisdom of the past to create a better tomorrow. My name's Rob Van Horn. I'm the operations manager for Passerelle, and it's my pleasure to welcome Dr. Sasseville today for his webinar. And with that, I'll turn it over to you, Maxime.
Thanks a lot for the invitation to the Passerelle team to talk about two things that are deeply passionate for me. So scientific writing and artificial intelligence, and trying with you to foster better use and thinking about these two things together. So I'll move a little bit forward, just talking about why am I presenting this and why the Passerelle team knew that I was interested in this and that I work in that field. It comes from frustration. I'm not someone that is good with role-based systems. And or rules-only based system without any explanation. And when I was starting my master's and advancing in my PhD, I became deeply frustrated that I had no understanding or no clear understanding of why writing was like that, why we do things the way we do, and that there is probably things behind it. But it was not explained to me, and it was not, it needed a lot of thought process. So that's why I said overthinking. You can also say maybe obsessing. That's a little bit the direction that I went. And now I think I can manage to say that I have better understanding of why we do things that way. And I'll try to do that with you today. Just a small thing that so you see my name, I'm first French. And this talk I usually do this talk in French. So please be empathetic towards me if I fumbles or search or things like that. If there's some typos in the presentation as well, I've rebuilt the thing that I was used to present. So please be welcoming to me. I also come from an empirical position, so science that collect data, analyzes data, regardless of your position, qualitative, quantitative. But what you'll see today is that this is a structure that is necessary if you're doing any kind of philosophical work or theoretical work. That will probably not be entirely suitable for where this talk comes from. And it's also not my expertise nor my experience. Um, this is the book that helped me frame my thinking about scientific writing. Um, in that book, they are really clear that if you want to be teaching in that field, these are the things you need to consider. So these are the things you need to be good at and that you should look yourself over self-reflecting about. I won't go through them. Most of them are public. What I can say to you is that this is the lens that I use to decide if I would build a course or not, or if I do these kinds of talks or not. And it's a lens that I'm constantly readjusting. Just saying that to you so that you can use your own lens with what you're seeing, because you can see that I'm quite young at the start of my career. So this is necessary for you to just understand where I come from and why this is suitable for you or not, the position that I'll be arguing today. So I've been working in the writing for science, adult education and training for deeply for 3 years now, but a little bit longer than that. Today, the plan is to start from there to kind of lay a foundation for you to meet me for where I come from, what I think is necessary to improve scientific writing. It's just a lens to help you get there. And after that, what we'll do is we will push the generative AI lens through this foundation and see where it can go wrong and what you can do about it so that it continue for you to go right. So that's the plan for today. So it's a talk in 2 acts, and we are starting the act 1 right now. So I like to start with questions. Why does this matters? So you probably have the experience or the thought process for yourself, thinking about, I'm not that good at communicating or at writing. Why should I bother? This is for other people that are good at it, and things like that. It's probably a rhetoric that you've observed or heard, or something that you've thought yourself, being in a situation that you were frustrated with how it was going or your own capacity. The first thing that I want you to think about today is that I want you to take the lens that science communication is not dissociable from scientific process, that science needs to be communicated. If you take the scientist's role as a society, or role as scientists is to conduct research. So to bring together our methodological and content expertise, design studies, and collect data, analyze data. Regardless of your epistemic lens, that's what you probably are doing. And this is in the goal of contributing to the overall human knowledge. So if you are not communicating it, why are you doing it? Because I don't have that answer, to be really frank. So it's not something that is that you need to choose to do. This is something that you have to do. And that can be in other form of communication. We are going toward the DORA principle that I really like. Today we are talking about writing, proper writing. I think it's the more prevalent way of communicating the result from research. But just the lens is to communication as a whole, not only writing. So you should communicate what you are doing, or you are doing that for absolutely nothing, because what you are producing is not used. I have three big learning principles of scientific writing on which we are going to lay on today. We'll go a little deeper into each, and that will be the end of Act 1 of this talk. We'll start with the shift of stance. So this is just a proper reflection about why writing as a whole is hard and is necessary. I want to help you try to understand why it is hard or emotionally demanding, and try to go from there to improve as a learner. Because if you are stuck in the learner stance and you are not moving to the research stance, you're going to have a bad time. That's going to be really hard to do. The second one, where we are going to go a little deeper, is the universality. That's a really hard English word for a French person, of scientific principle. So I'll try to make the case to you that you should, as I have just, I hope, made a clear case of scientific communication is the end of scientific process. Because of that, all the principle also apply to scientific writing. So the same principle of scientific processes. So we're gonna go deeper in that. And after that, when all these two main building blocks will be done, we'll go to how do we build skill on top of that? So now that we understand why we are doing things a certain way, now what you need to do to improve. So really, in a pragmatic manner, try to build and give you tips and things you can focus on. If you're not already doing them, they'll be easy to introduce in your work. I forgot to say something in the acknowledgement. If you are waiting for the PDF version of my talk, you'll be unsatisfied, because this is the way it's going to be the entire talk. I talk more than I show, so won't be a lot of text. So if you are really interested in this topic, please take notes, because that's just the way I'm trying to convey things. I'm starting principle 1 with a case study. So I've said that stance shift needs to happen when you are moving for learners, when you are moving from a learning perspective to an academic researcher perspective. So master and a PhD student are researcher. If people say to you that you are not researcher, they are wrong. You are learning researchers. So you need to take that stance. So the learning studies, when I built my course, I tried to find the oldest scientific thing I've written. So this is mine. That's exactly what, first starting masters, first abstract submitted to a conference. So a little bit of context. As many of you, we are all brilliant people in the same rooms. So we are, as me, you probably are at the top of classes, used to having good grades and always encouraging comments about your performance and success. So that's the lens I had when I arrived at the master degree. And when I wrote this, I also went to five English summer school to reach literary English level. So I'm confident this is the best thing that I've ever wrote, or almost. This is the summit of my competencies in scientific writing as a master's student, what I felt like. And you probably know where I'm going with this, but this is what I receive. So this is not exactly how I thought it would go. So my supervisor went through my writing and rewrote everything. And I've done this talk and this case to understand that it's probably you had this experience in some way at some point, and it's a hard one to live. And it has kind of a reason to be, and nobody is doing anything or trying to do anything about it. But this is really harsh because you are reconsidering your just should you be doing graduate study? You probably don't have the skills, or you don't have you're not intelligent enough, and we are kind of good at reducing ourselves, scientists. So this was quite hard. Why does that happen? I have a lot of questions, but I won't ask to you to answer with the group that is connected. But this is the way the talk is structured. Writing is suffering. This is what I had, what I learned from that experience. Writing is suffering, but is it really? So does it needs to be all the time, and can it be easier? We have a little bit of data about this, but what happened to me and to other people is that we are accustomed to receive positive feedback. We were top of class all the time and receive always good grades. And we get there and we are, okay, there's a shift in the comments that I receive. And this is the shift of a science researcher. You get to a point where now these are colleagues. So a supervisor are colleagues. You are going toward a researcher route. So colleagues do not seek to not criticize you. They criticize the science that you've done. So I was seeing something like I was criticized, but in reality, this was not the case. This was the science that I was pushing forward. This is the first important principle, because the sooner you are able to understand and operationalize this in your scientific life, your scientific writing, no comment can be badly received. You are rapidly improving, because the comments, you will not be resisting to comments. You will not be resisting to other point of view or things like that. So just keep in mind that every comment received at any point, supervisor or peer reviewer or even peer reviewer too, these are all brilliant people that are commenting the science that you're doing, and there are at least a little right. If you take that as a hard truth, everything will be easier. So that's the first learning principle about why the shift to scientific writing is hard. We are going now to the second principle about the universality of scientific principle. So that's a question that I ask groups and class, just about what they think is science. So that seems probably a simple question. It's quite a hard question. And in my experience, it's a hard question to answer. And they will get to contributing to knowledge, improving the life of people. The longer we got, we stayed in that place exchanging was, I think, 7 to 8 minutes without really getting to what is science. If you took the time to reflect a little bit and answer this question for yourself, you maybe came to that point. Science is the scientific method. So it is the simplest way of looking at it, and it's the easiest way to see how, if you take science as the scientific method, how it can improve your writing. So if you take science as a structure built upon fact, and you go to, so that's a really good book about scientific method. So you can go a little deeper about that and think a little deeper, but at the end point, this is what it should finish at. You should always start as science is the scientific method. It's not the outcome. It's not. So it is how we structure things to look at, to observe reality and try to attain, be the closest possibly to the real truth, which we never know what it is, but we think we are the nearest by reducing bias in the method. So what why I am saying that to you. So what does that mean for writing? That means that if you take science as technique to reducing methodological bias and you apply that same lens to scientific writing, you are now able to see the prolongation, to see the linkage between scientific method and scientific writing. If you see scientific writing as techniques to minimize interpretive bias, so a reader that will read your paper or writing will have the right interpretation of what you've done, what you find, and what you think it means. So you need to reduce the distance between our reader will get this information and manage it and use it, and how you are conveying it. So that's just that was a late last night addition. I'm not sure yet if that was right or not, but it's just I want to solidify that thought of maybe with an image. That's a cheeky image to use, but if you take principle of integrity, scientific transparency, and scientific precision, those can be matched between method and writing, and that's what you should do. So you should really see science writing as an extension and apply the same epistemic choices to produce that work. So now that we've kind of built what I wanted to wanted this group to have in mind, when we'll go to the pragmatic use of some tools. So we've seen that science quality is the object of the criticism, not yourself. So you should take that as way forward, and that scientific writing is part of science and held to the same standards. We can now begin to go into why rules exist. So why there is things that people say that you should do without saying why. So they all have reasons. We won't have time to do all the reasons, but we'll do kind of just enough so that you can put weight onto what people are saying to you. So yeah, I don't want to go too far into a tangent, but so that gets us to principle 3 about literacy. So skill set. How do you build skill set and improve as a scientific writer? You just need to kind of put behind the idea that you should write with complex words and complex ideas, and just get to the point where you should write about science in a simpler and clear way. That's it. If you are looking to, okay, you're doing scientific processes to write your results, and that your results are used, to be used, you need to be clear. It needs to be precise so that people can use what you've said and done. This is a book that was suggested to me at the PhD level by my supervisor, without context. Just, this is something that you should use. So going in the same way as rule-based mentorship and not like principle of why things are that way. This bugged me a long time, and I was not really using the book until later. English writer probably are really familiar with this book. What I want to say to you, if you've never seen this book that way, is that almost every point there works in a direction of enhancing clarity, precision, and scientific integrity. So we're going to go a little deeper into some of these, but if you take that lens while looking at that book, it is now a lot clearer why scientists like it. It's also really small and to the point, really pragmatic. So as pragmatic creature, I think we kind of like that. These are the 6 points that I usually go, 7 points that I usually go a little deeper. We won't do 7 today. We don't have time. We'll do 3. Okay, that's one thing that if you keep something today from that talk, and it's only that, that's a winning. That's a win on my side, okay? From now on, when you're starting to write, you need to separate production from edition. You need to do productive or generative writing in a session and editing in another. I'll make the case why you should do that. First, you need to just write. So no judgment. You have a narrative thread in your mind that could be from general to specific or from argument to argument. You have something you want to say to structure an introduction or to structure a discussion or anything that looks like it. You need to accept that this step is imperfect and you need to just push as much words on the page as possible. So if you work into structuring your paragraphs and ideas before writing, or if you're just free writing, doesn't really matter. Just take something that works for you and just write without doing any edition. Why is that? It's because this is two cognitively different processes, okay? When you're doing generative, when you generate words, narrative threads and things like that, your mind tolerates the ambiguity of what you are trying to say. And what you are really aligned on is this is the line, this is the story, the narrative, the direction I need to go. If you stop this to edit a sentence or structure something, you're going to cut that out. It is more true for beginners and it gets less true for experience or expert. Data on that subject has shown that. But it is probably a good safe bet that you are in the 99% of people that should separate it. So just accept that. The sooner you're going to do it, the easier it will get. You produce on one session and you edit on another session. So what is really, really important is to separate it, and at first separate it with time, okay? Sometimes if you get experience, you could write deeply just the text and you're getting better, so the structure is better at first draft, and just stop there and take a break to lunch and be able to edit afterward. It's unlikely that you will be able to do that at first. And why is that? Is that you are emotionally attached to what you've written. You need to take the time necessary to look at the text you've written as an audience member, to be able to cut, restructure, and change things. You probably have the general experience to, instead of cutting, moving things to the end of a page or a text. This needs to stop to happen completely. So if you get better at this, you'll see yourself as an audience member, and this is text from almost a stranger, but you will not see the burden of putting that word onto the page. So what it took to get there. And this is a suggested structure of how to get there. So you need to structure into generation and editing, and after that, multi-phase editing. We'll get a little deeper into these phases: macro, micro, and polish. If you want to build better paragraph, you need to first structure one ID, one paragraph. That's it. If you take just that as a rule, it's that, okay, I have one key message that I want to have at the end of this paragraph. This needs to be it, and you need to move forward. If you do that, your logical flow will improve. And after that, it's a lot easier to work a paragraph in an enclosed manner than if it works well with another ID that is linking. And so you're gonna have a lot of difficulty. So if you get to that point where you are working on logical flow, you're working on parallel structure, so more grammatical work into how things are presented, and ruthless editing. So having enough emotional distance to be able to cut your things that you've written, you'll get there. 3 small techniques at the sentence level. So I went faster because this is just, we're going to go deep into the three of them. The first technique is to cut unnecessary word. So I think it's pretty apparent what happened here with the example. And you have at the bottom crunches. That's direct French translation of what I use in the course as béquille. And I'll say why I use this image is that if you are using these culprit, these problematic structure, you are able to write. So it helps you write. It helps you generate text, but it won't get you to a really good text. So at the editing phase, you need to cut that out. And I'll make a case of why these things are problematic. If you have sentence starters, like as well known, it should be noted that what it does is that it masks the difficult argumentative liaison. So you have gaps in your argumentation, and it fills that out because you were writing and you just were in the flow. So if you cut them out, it will be easier. It's easy to find. So if you see kind of a heavy start of a sentence with a comma, just cut it out and try the sentence that way. What does it look like now? Is it now cut from the rest of the argumentation? So that's a good information. That it means that you should improve how it is presented. Empty adjective are really big culprit. What they do is that they remove the ability to prove what you've written. So if you write that something is important or innovative, I really hate innovative, by the way, you are removing yourself into proving to the reader that it is innovative. So it is really kind of just a secure way of making a point without making it. So if you cut that all out, it is going to show really rapidly that you have empty sentences. So what will happen is that you'll have subject, verb, and without any point. Something is innovative. Okay, but say why it is instead of saying that it is. This is science that you're writing about, not an essay. Same thing for adverbs. The other point that you probably heard again and again and again is to use active voice. I'm not sure you have heard why you should. I'm going to try my best to explain to you why it is important for scientific precision. When you are writing in the passive form, as the red example, you are removing the responsibility of the people that have done the things. So if you are writing your method at the passive tense, what will happen is that you take no responsibility and you are not saying who made which decision and why it was taken. So you can see in the two examples that the second sentences, if you write that out in your method, you'll feel really bad about this sentence and you'll make the effort to better present it and why it was important to take that decision and what is behind it. So you'll be more precise and it will be easier to use your data without being afraid that they are biased results. And if you get just to the point of easy to read, it improves readability and it reduces ambiguity. So clearer and actively easier to read. The third technique, and harder to point out, because the other points you've seen is they are easy to see when you're doing the editing. It's weight at the beginning or ending of sentences, adverbs and modifier and things like that. So you get really easily faster into seeing them, highlighting them, and working them out. This is a little harder, and you need to think about what you've done, what you are saying, what you are describing, and if you move the verb of the action you've taken as a team or as an individual, and you're moving that to an adjective, you'll get a really weak sentences. So if you get to the point of when you find a sentence that is hard to read or longer or it's harder to see the point, and you'll probably see that you've moved the verb to another role in the sentence, in a noun most often. So move that back to a verb and it will improve your sentences really rapidly. This is what it looks like if you get somewhat good at just these three things. So you have just you have a movement with a green highlighted sentence, but just being good at finding text that is your crunches, the things that you've inserted in your text to make it easier to write, you'll improve really rapidly and your editing will be easier. And after that, while you'll do other work, other refinement, it will improve. So these are pragmatic ways to improve your writing into strong foundation of how it should be. So how I want you to try to frame that, if you get any kind of hints or advice about scientific writing from now on, think about it in a scientific method way. Is that advice aligned with more clarity, being more precise, and things like that? So if you do that, any advice can be instantly inserted or maybe left alone if it's not the right direction. So now we get to probably why a lot of you are here, because you've probably had a lot of talks about writing. I hope this one was a little bit more insightful, I hope, because it took 10 years of reflecting and engaging with that subject. So I hope that was helpful. And now I'm going to make the case into how to integrate generative AI into these principles. So that's just a joke. I won't go deeper into that. How does it work? It's just simply how to so that we are at the same level and on the, because the problem that generative AI have is linked to the way it works. So I want to just putting main things because it's can get a lot more complicated and other kind of processes can also be there. But at the basic level, you get predictive models. So if you've worked with regression model or things like that try to predict what will come, using parameters that you insert in the model. Here, the parameters are words. You get, if you take the entire human production of literary work, you get to something that is probably better than we all could have anticipated first. And the way you get there is to, so when you use a generative AI model, so I may say large language model, so these are not quite synonyms, but I'm talking about the same thing. You are using a sequential prediction. So it's not computing words per words to be beautiful. It's the way it works. So it has a context window where all its information is, the question that you've asked, the way it was structured, and it generates a word and put it back in the context window and advance. So it cannot look forward into what it will write about. That's why it's unable to count in any way. So it just push forward. So it's just a way to think about this. And this is important because if you think about using a predictive model like that to do scientific research or literature review, I think you can fastly and rapidly see where problems will happen. Because LLMs can produce text that looks like science more than that is science. So it's really good at mimicking what it's supposed to look like because it's a predictive model, but it's rarely a good scientific process using integrity and transparency. It is good so it is performant. I won't hide that. So that's why a lot of people use it. You can see on the right, it is skill-based research. So they've compared a group that had access to AI and a group that didn't on the same task. So it's a knowledge-based task. And you can see that the blue curve is significantly skewed toward higher score. So it works for knowledge-based tasks. That's why there is insertion and there is validity of using them. That's why I've wrote faster and sometimes better, because it depends what you use it for. It can hinders your ability to do science and sometimes to go fast because it can slow you down. Fairly good to go superficially into the literature and start writing. Preliminative, I won't go too deep into preliminary analysis. We won't have time today, but it's something that is really used right now. So what does responsible integration look like now? So I said, you can probably use it, and I think it is right, and it's probably what your university says to students or to people. But you kind of need to be aware that all the guideline for authorship for science mention that AI cannot be mentioned as an author first. So that means you are doing ghostwriting. So that's fairly problematic because that's an action that can be linked to scientific misconduct. So in the same way as data manipulation, I don't think you want to be in that position. So be really cognizant that using AI to build a paper and not really look at anything or confirm anything or things like that can be really problematic in a matter that is really hard to come back from. So you need to supervise, validate, and document what you're doing. I will go deeper into these. Because at the end, you will take the responsibility of the output produced. So think about a senior researcher doing work with an intern or a master's student and taking an authorship role or a lab director role. You are taking the responsibility. So usually you give some guideline to a newcomer into a team into how we do that. We do research in that team. So you need to have this kind of thought process as well. What's the risk? Like clearly and precisely, what is the risk that you are taking by using AI so that you need to be aware of? The one that are easier to spot and check for is plausible but inaccurate content. So this is a paper that was out in 2025, but this is largely true for all the population that use AI to ask question. Because being really good predictive model, it's also being really good at convincing you that this is the right answer, even when it's wrong. Because it's said the model has been reinforced with positive interaction with the user, with billions and billions of interaction. So they are really, really, really well tuned to be convincing of anything because it promotes engagement and they want you to use it. So be really, really cautious about that. I'll go to the third point directly. We now understand a little better that scientists, when they use AI and they receive a long answer, have an automatic cognitive bias because long answers are seen as more adequate, more complete, and they won't go into verifying them or trying to give the other side of the coin, for example. So you need to be really cautious that this is happening. So the risk is not that something is really obviously wrong, is that the model is convincing you that this is right and this is really wrong behind the scene. The other to detect things that can happen with time is things that are now documented, progressive dependency, speed as it. So I'm kind of cognition of the time. I don't want to go too deep, but some speak for themselves. For themselves. I'll go a little deeper into speed as a trap. Is that everybody's afraid of the white page. So you kind of go to an LLM and make a draft with it. That's not entirely wrong to do if you are going the responsible way. So you're gonna monitor, counter, verify everything, go deeper into primary sources. It's gonna use only open source available data, so you won't have all the closed source data. So you'll have just a section of the entire your scientific discipline. So you probably will lose time instead of gain time than doing something that is aligned to your expertise. I want to make just a small point about that, just to talk about the slippery slope of using too much AI. This is fresh data from 2026 that is still in peer review. If you are somewhat cognizant of the Dunning-Kruger effect, the blue line that you see on the graph on the right, it is a well-known psychological phenomena that links self-evaluation about expertise and real expertise. So it has been replicated and showed in every discipline and everywhere that when you start the acquisition of a new expertise, you overestimated your own expertise. And it gets down really later when you are getting really better. And why is that? Is that because the simple phrase that people will tell is you don't know what you don't know. So further you get into the expert direction, the less confident about your expertise you become. And we kind of see that everywhere. What is really, I think, dangerous and potentially dangerous, because I just wanted you to have that in mind when you think about AI use, is that you can see the green line is actual. So this is a study with people engaging with AI to do knowledge-based tasks. You have the green line that is actual performance, and the yellow line that is the self-perceived performance. So what you can see is the dangerous side of things is that there is no movement toward an adjustment of knowing what you don't know. So you always are quite confident that you are the expert in the room, and it never get down to a place where you signal uncertainties and go deeper, and that's what an expert is about. So just want you to think about that. So these are other documented impact. I'll just focus on one. The one at bottom right. AI literacy amplify overconfidence. So they've tried what I've just talked about and try to improve AI literacy, talking about how it works and how to engage with it. It kind of don't really work if you still use AI for everything. So if you continue to use AI while being really cognizant about how it works, doesn't get really better, and it worsens. You are more confident because you think you know how it works and that you are kind of protected. So just want you to have that in mind. So pragmatic now. What you can do now. You need to map how you will use generative AI in your work. So where it enters and what is its purpose, instead of just the first thing you do if you are doing that. My recommendation is to draft first and query second, because you won't be biased in that direction. So if you are coming up with your plan, and after that, following your plan and contrasting it and kind of poking holes with an LLM in your argumentation, that's really good. But you should not draft things at first with it to keep your reflection and your competencies as a researcher. You should question the tool. So request where uncertainty is. So if you link that up with what I've presented, you can understand that it will be really convincing at having a full portrait, and you will be biased into thinking that it's full. So go toward asking question about what are the gaps, what are things that it's not able to show right now. Document everything right now. So if you are moving forward and using it, create a markdown file, an Excel sheet, whatever it is. if you use a model, what was the date? What was the model? What question you ask? Do you have something in the context window? So everything that you are doing, if you're doing it for a scientific project, in the same way you would do for SAS or R, the package you use, which version. So this is the same thing. It's a tool for science. You need to treat it as such. Now linking that with principles. If we link it with shift of stance, the first principle, what you'll do with AI is to think it about an interlocutor, somebody you can brainstorm with and exchange, because you want to grow as a researcher and be more criticized about the science you produce. If you look at the science principle, you need to take responsibility for what you are writing and the epistemology you're using. So you are the only person that is responsible for the quality of the work and the quality of the method you're pushing forward. And finally, about scientific writing literacy, you need to move for a goal to be a reader and an editor in your work. If you can't do it properly or verify scientificity of what you have written, you're just not yet literate enough. So you don't have acquired the skill necessary to be able to qualify as an expert in that field or in that structure. So be really cognizant about prompting yourself about where you are. And that ends things now. Did a little longer. I hope we'll be able to take some questions.
Thank you so much, Maxime, for that great talk and really interesting dive into how to best kind of use it and safeguards for scientific writing and helping people to really understand that. One question that we have right off the bat from Rudy was, how do you properly cite AI in writing for in-text citations and formal references?
You can't. Mostly. So you should work toward in the same way where you don't want to secondary source or a blog post or something like that. If it reference a primary source, you should go to the primary source and verify. That's why the way I frame the responsible use is to monitor and verify. So if it gets to a point where it kind of say, oh, that kind of that research group showed that in that paper, and you can find it, it could be hallucinated because it's a predictive model. So you can ask the model where it took that information and verify it to the deepest degree to be sure that this is real info, because this is not Wikipedia. This is a predictive model. So it will, by its function and form, hallucinate because it is just predicting to be a good language interface. So you don't cite AI, go to primary sources.
Yeah, great tip. Thanks. From Kava, it was the question is, would you please introduce some AIs that would be useful for clinical research?
So I'm not sure I understand well. So AI is a group of techniques. So I'm not sure. So if you think about AI as semantic clustering, for example, or things like that. So I'm not really sure what the question is.
I'm wondering if it's maybe some of the different like engines that are out there. So ChatGPT versus some others that exist, perhaps.
Yep. So you kind of can probably use anything, but be just cognizant that there is some loss in transparency if you go to commercial route. So if you use Claude or ChatGPT, you won't know what the context framing is. So how they railroad the model to insert to you in a certain way. So that's not transparent. So you don't really know how to use it. And if you move really toward using generative AI for research methods, so that's a different beast than what I've presented here. You should move toward local deployment. So to a computer where you are kind of being able to control every parameters and things you've done with the model, and you've kind of framed the model in a certain matter. So if you think about using it in scientific process, not in scientific writing, you should go to that route. Because in scientific process, if you're using commercial route, you have a black box that is incompatible with research methods. So that should be clear for everyone, is that if you are using ChatGPT at a date versus another date, something can be changed in the back end of how it works, and your prompt will not be able to be reproduced. So you need to be cautious, and if you are moving toward that route, so just you'll need a little bit more skills to try to do it.
Great, thanks. So one that kind of dovetails with that is, do you have any suggestions for AI tools to find references or summarized papers?
Yep. I'll say probably any tool that you currently have access to, because they all have about the same limitation. So if you use Elicit, for example, which is probably the best one, it's still blocked by not having access to full text article, so only what's referenced on the web, and sometimes they will block web scraping, some editors, so you'll have open access paper. So if you use the web search in a commercially available tool, it'll have a limitation aligned with how editors are publishing science. So they are protecting paper behind paywalls. If it is protected behind a paywall, you will have a lot of difficulty getting it. And you probably won't be able to. And the solution that really do well in that regards are two solutions. I could send it back in an email afterward, but they are the one that are supported or suggested by Cochrane right now, but they are validating these right now, and they are incredibly costly because they need to pay the API to the editors because it's a commercial solution. So it can be up to $3,000 per review with these solution. So just keep in mind that you can use probably anything, but they have inherent limitation in how they work. Is that they have access only to what is open access or what is allowed as for web scraping. And you can test that out with the one that you're probably using. If you are, sometimes you'll have kind of incoherent things. So they'll say something that you'll have an output and you'll go verify. And it's not at all what it's saying. It's only the title. That's because it was not able to go further than just the title that was probably in the search, the main search. So it was not able to scrape the page because it was blocked by the editorial team. So yeah, just be cautious and probably almost anything, but with responsible use in mind. Verify everything, you need to be able to take the responsibility for what was found and all that stuff. But yeah, they are mostly all fairly good at doing that.
Okay, great. There was a few more questions here. I don't know if we're going to have time to answer them all. There was a question about whether the slides could be shared. I know
They
you
will.
had mentioned. Yeah, okay, perfect. And then maybe one more here. Are there functions of AI to improve writing that are quote unquote less risky, such as editing your text for grammar or to make sentences more concise?
Yep, absolutely.
Yeah.
So this is one of the use I think that is the most helpful for a French person like me myself. So sometimes it's not as easy to see the syntactic problem in a sentence or a group of sentence because you kind of try to manage all the things. But if you think about it, okay, do I own the way it is structured? Have I edited the argument? Am I sure that what I've written in this is what the primary source is really saying? and that now I'm at the phase where it needs to be a little more impactful, better presented. That's where LLM tools are really fantastic because you already know that what you have written is truth, is near the truth with bias, and now you kind of just need to be a little better at presenting it, and that's where they really shine. And the risk is low to inexistent. So where you can have risk is if you have like the primary text that is in a copyrighted paper and you put it in an LLM, it's not a right use of the copyright. So be cautious about things like that. But if you are inputting your own writing into restructuring, completely adequate. But you need to, editor now and journal now ask you to declare it. So you'll need to declare that you've used it for syntactic rework or grammatical rework.
Okay, great. Just before we transition over to the fellows meet and greet, maybe one or two more questions. So the next one is, how does AI respect data sovereignty or ownership? For instance, if you're refining a paragraph that includes collected data or using AI to refine collected data, what happens to that data that is input into the generative AI in regards to data ownership?
That's a super good question. I'll try to do. I'll do my best to be as concise as possible. If you look at the term and condition of the tool you're using, they'll say if they are using your data to improve the model, but or not. What you need to understand is that most of the time, for almost all the commercial solution, they are not storing any data for the model. So when we say that the data is in the model, it's not really there. It's there as parameters. So it's there as weights. So you can, if the data is highly prevalent, for example, if you want to reconstruct Alice in Wonderland, you'll be able to do it with almost word-to-word exactitude because you have so many sources that in the model it was really prevalent. So the prediction will be easier to do. But if they use kind of your data for reinforcement, what they'll do is shift weights to improve prediction, but the data itself is not there anymore. Where I think you can be a little bit more cautious is if you use any commercial solution where you can ask the model like Claude or OpenAI, ChatGPT, to store information on you. So that's where I think you need to be cautious, because if you are pushing data, protected data, anyway, you should not push any protected data in an LLM ever. If you want to do that, use closed model, open weight model on a computer, not on the internet. So don't think about using qualitative data in a model, but just be cautious about what you're using, and if you're breaching your scientific integrity of data protection. So you have signed with the ethics committee and a consent with the participant. So you need to follow that. That's why it's really easier to not think about generative AI as a different beast than scientific method as a whole. So if you are using that tool for scientific writing, and that scientific writing is part of what all the other step of science is, it is the same structure. It is the same basic principle that you need to follow. I hope that helps a little, because
That's
that
great.
was a complicated question to answer.
Yeah, no, it's a good reminder though to kind of always refer back to the ethics principles there for sure. And maybe the final question that we can take today, is there a good way to use an AI generated paraphrase or summary of an original text. So is this an acceptable practice after verifying that the original content is, accurate or respected?
So I'll make a different case. So if you are using kind of word for word an argument that you want to paraphrase and put it back in your work, what I'll do is that it will be a weak argument. That's it. So that's the lens I think you should look at it. And it'll be the same weak argument as if you would do it yourself. And why is that? You are not transforming or pushing forward the interpretation of the primary author. So I think we get these questions when you start to write. This is one of the manner that you kind of build an argument. You build your argument on other scientific argument. So what I encourage you to do a little differently is because it is bad practice, even if you're not using an LLM, so a generative AI. So try to get rid of it entirely by not paraphrasing, by taking what the content was. Why do you need that information in your argument? Is it linking to other arguments from other authors? So now you get rid of the problem of paraphrasing because you're building something that is better or larger or more suitable to your needs. So there's probably kind of a million different tools that will do exactly what you're talking about, but it won't improve your writing. So I would encourage to go a different route of thinking about it. But yeah, it's kind of answering the question without answering it. So I hope it was just a little bit helpful. But yeah.
Excellent. Thank you. Well, I want to thank everyone for joining today. Very insightful, and hopefully it was useful for everyone. And thank you so much, Dr. Sasseville, for your great presentation and for taking the extra time to answer questions today.
It was super fun. Thanks for everyone that is still there to being present. So I was seeing the big blob of people, of number of people. Thanks a lot. That's really encouraging.
All right. Thanks, everyone. Take care.